Hello, everyone. It's a real pleasure and honor to be here. And congrats and kudos to the organizers for the great event already. It's a success. And for the last 5 years, I was involved quite deeply into the crypto space. And let's say, on my eyes, it evolved from almost like something really marginal phenomena to very significant part, I guess, of the world financial system. And for me, it reminds me of the Cambrian explosion of life forms. If you look at the crypto space, how many different projects, you have like 6,000 coins out there. And there are many projects which are in the hidden mode, just building some like innovations. You have already like 400 exchanges globally. And it's very open and wild environment where they compete to each other, like borrow from each other. Many projects are mainly open source, so you see like a very speed, evolution in very high speed. And the frequency of events in my life in the last years were like 10 times more than in my previous career in IT. And so I want to talk about my perception of this evolution. What is the state currently, and where are we going in terms of the scalability? Because I think scalability is one of the main issue of the adoption of cryptos. So cryptos, in my opinion, is the private money. So this is the attempt of the society to create some, to detach the money from the state and create some private monies which have the same properties as Martin has nicely outlined: the store of value, the means of exchange, and unit of measure. And still there is, the old world actually thinks it's still not a threat. Like Christine Lagarde was speaking at the Bank of England for their anniversary, and she mentioned that one of the biggest innovations for the next 40 years will be like artificial intelligence, new financial intermediaries, and digital currencies. And for now, she said that these currencies are not a threat to the fiat money because they are too volatile, they're too risky, too energy intensive. She referred to Bitcoin, and because the technologies are not yet scalable. But those are technological challenges which can be resolved over time. And now she's the head of the ECB, and I think last week the ECB paper went out on the stablecoin in the euro area. But is the statement really true? Basically, the volatility is really high on the crypto markets. If you look at the daily volatility of the Bitcoin, is around, actually mainly around 3%, but it's going also up to 7% per day. So you basically have some really rude jumps intraday where the price can drop dramatically or increase. It's 5 to 10 times more than compared to the asset classes like gold and fiat currencies, which of course is not very convenient for transactions even intraday. When you send the Bitcoin, you have to wait maybe 3-6 blocks, like a 1-hour confirmation time. And during this 1 hour, the price of the Bitcoin can really, increase or drop dramatically. The risky part, yes, also Martin has mentioned, there's a new types of risk. The cyber risks are involved. Bitcoin itself and cryptocurrencies are based on strong cryptography. So by design, they're super secure. You cannot hack the Bitcoin because they're based on the strong cryptographic primitives. But the weak point in this design is the end users, because they now have the public keys and the private keys they actually use to transact, and those private keys is the point of failure, because you can be attacked by, the exchange can be attacked by the insiders or some hackers. The user can lose his private key, and by this losing the access to the funds. So, and it's only get accelerating. The total hacks exceeds actually $1 billion last total. The energy intensity, it is a kind of a concern of especially the eco-related crowd. The total energy consumption for the Bitcoin now is close to 80 terawatt hours per year, which generates the cost of like $2 to $4 billion, depends on the price of electricity, and which creates a footprint of 35 megatons of CO2. The miners actually which kind of use this energy to mine Bitcoins, to validate Bitcoin blockchain, they have to then sell those coins to cover their costs, basically. So the premium at which they sell now is around 6 billion per year. So you make the slight margin there, but still it's by many is used to be too high, because this amount of consumption is compared to the country like Austria or Switzerland, so it's already like in the top 20, let's say, countries. And the scalability is the kind of thing which is a concern of the current design, because Bitcoin by the architecture of Satoshi Nakamoto was had some parameters, like with the block size. Maximum block size is 1 megabyte, which can fit the 4,000 transaction, and every block, the block time between the blocks is around 10 minutes. So basically, you can have only up to now with Segwit up to 10 to 12 transactions per second on the Bitcoin blockchain. And it's not even at that level. Currently, if you look at the daily transactions, it's around like 300,000 transactions per day, which is roughly 4 transactions per second. This is quite small even compared to the world remittance. Like Western Union does the 9 transactions per second in total. Like average remittance, Swift does the 130, and PayPal even more, and Visa, of course, even much more. So, there are solutions actually for volatility, various types of stable coins, but I'll more focus on the scaling, on how to scale the technology level to actually onboard more users and to provide more capacity for transacting. There are actually basically 2 types of strategies there. There is a layer 1 and layer 2. Layer 1 is the main strategy now for the Bitcoin to scale. They introduce the payment channels, so-called Lightning Network, and as well as side chains. So you can create a smaller chain, maybe with a bit less security, but faster in terms of transaction per second, and you can there scale. Then there is a layer 1. There is actually basically you can increase the block size or decrease the block time between the block generation, and it's called the bigger blocker strategy. And some blockchains actually follow those strategies. There is very promising way of doing the sharding. Basically, you can run some chains in parallel and create a secure setup that they actually are synchronized. And in this case, you can actually n times speed up the blockchain, let's say, because we have n shards, they are processed in parallel. Then there is a lot of progress in the proof of stake architecture and committee-based consensus, which is used now, for example, for Ethereum 2.0. The Casper is based on proof of stake and committee consensus, and this is rather scalable in terms of both the number of nodes and transactions per second, and also DAGs, like decentralized cyclical graphs. When you change the topology of the blockchain, actually it's not a chain anymore. It's a kind of a graph where you can connect transactions and blocks to each other. And this is also a way, still experimental, but to increase this capacity. A couple of thoughts about the vertical scaling, about the Lightning Network. Lightning took off maybe like 2 years ago with the white paper of Joseph Poon, and it's now actively developed in Bitcoin community. So basically, you create a level 2 on top of the Bitcoin blockchain. Every channel is like a peer-to-peer channel with either the hub or some other user. And we can put some amount of Bitcoin in this channel, like a collateral, and then transact off the chain. So we can send some messages, like transactions, and sign it with our private keys. But those doesn't touch the main chain. So the chain is just used for dispute resolution. And whenever there is a dispute, let's say one party doesn't agree with the balance of their interactions, they may broadcast some transactions which they have, we think they write, and there is a mechanism which resolves those disputes in favor of those who actually has the right balance. And this layer 2 scaling has some advantages. Like I say, it's really not limited anymore to the blockchain. You can like millions of messages per second, doesn't matter. The safety is guaranteed by this blockchain collateral mechanism, and doesn't require the trust still, because we cannot know the counterparty, just still transact with him or her. And it's quite low costs. I mean, basically, it's almost zero cost. And the problems with this approach is that it still requires the on-chain transactions. You need to open channels. You need to sometimes close them and reopen and like add more collateral there. The medium payments in the channel is around now $5. So basically, you can only transact small amounts, like maybe $1, like paying for coffee, but not even the $20 or like $100. And the biggest problem that we also faced in Lykke is the hubs, those big hubs which connect to many nodes. They have to have a lot of capital frozen in the channels. So basically, it's a very capital-intensive process to actually operate the hub. And nevertheless, they still make very few money. For example, there was a message that a person actually put like 5 million worth of Bitcoin to the Lightning Network in the hub, and still makes like $20 per month out of this. And we also faced this already in December 2017 at Lykke, where we created this decentralized exchange and cleared the trades, the Bitcoin trades, and settled them immediately on the blockchain. We used the micropayment channels to actually not to face this on-chain constraints. By December 2017, we had like 6,000 channels opened, with already like 8 million of Bitcoins frozen in the channels. And to operate these channels were actually really costly. So, and at this point of time, actually also the price of the Bitcoin surged like to $19,000 per Bitcoin, and we end up paying like really a lot of fees to clear. Just to close those channels, we paid like almost like $500,000 in fees for the network. So this is kind of was the wake-up call that it's not work. I mean, it probably doesn't work, and this light network will have this inherent problem of the economics of the hubs. And what we see now in the developments is really going slower. So we have like now, this is the total amount of nodes, around 5,000 nodes in the Lightning Network, and around 40K channels. And you see it's kind of not evolving. So it's a bit of a stuck at the amount, which is frozen in the channels, and the transactions are like not really taking off. So it's more interesting to speak about the layer one strategies, probably to look something beyond Bitcoin, what is there, what works. And so we have some, as I mentioned, big blockers, like for example, Bitcoin Cash. They forked the Bitcoin blockchain and increased the block size by 8 times, up to 8 megabytes. Then there was another fork of the Bitcoin Satoshi Vision, like launched by Craig Wright, who claims like some to like even further increase the block size to 128 megabytes, the maximum block size. There are some sharding attempts like Zilliq and Near and Polkadot. As I mentioned, Post Committee, the like Algorand and Ethereum 2.0 and DAX. So how to like think about those metrics? You can think about the capacity of transactions per second, which is just a pure like throughput of the chain, like how many settlements you can have per second. How fast the settlement is, like what is the finality of the payment. Another dimension is decentralization. So we can not only speak about scalability in terms of the transactions, but also scalability in terms of number of nodes. So how many independent nodes there could be in the system, and as well as security. So what is the attack surface? What is the cost of attack for the blockchain? And there is this famous scalability trilemma, which says that you cannot have like 3 properties at once. So if it's secure blockchain, it's either with very high throughput, but with like low decentralization, like very few number of nodes, or is very decentralized with many nodes, but not high throughput. And it's basically what we see also in topologies. If you have a network with really many nodes, which are like distributed across the globe, like the Bitcoin now has 100,000 full nodes across the globe, and 10,000 of listening nodes, and around like 15 mining pools. So it's really decentralized in terms of the nodes, but it's really slow in terms of transactions, like 10 per second. Then we have this hybrid architecture, which is federated blockchains like EOS, or maybe like Stellar or Ripple or Libra or R3 Corda. There has much less nodes. It's different types of consensus, Byzantine fault tolerance, Byzantine agreement consensus, with maybe 10 to 20 to 100 nodes maximum. But they're like really heavy nodes. They synchronize fast, but you cannot have more than 100 probably. So it's a limit of like, they not scale beyond the in terms of number of nodes. And so I put it all together in one graph. So I put the maximum number of writing nodes here, like it's a log scale, and maximum like peak capacity of transactions per second. And basically, you see like two big groups. Like on one extreme is Nakamoto consensus with proof of work, where like with the Bitcoin having like 10,000 of listening nodes and like around 10 to 12 per second transactions. Then you have the Bitcoin Cash, which has bigger blocks, but because the blocks are bigger, the nodes are more heavier, and you have less nodes. And Bitcoin Satoshi vision is even less nodes. So basically, they kind of move along this line to the area where's the like federated blockchains, which has like 10 to 20 to 40 like validators there in the network. But of course, they're able to process faster, up to like 4,000 to 5,000 transactions per second in these blockchains. And we have some like promising techniques, like for example, Algorand is now live. It's an MIT project by Stefano Micali. So they are able to really scale in terms of number of nodes, writing nodes, and also Zilliqa is a sharding blockchain. There is still a large problem in the open networks, which is linked with collusion, especially when you have a like small number of nodes, like in EOS or Stellar or Ripple. Basically, you have 20 guys, 20 like controlling, agents which can collude. They get on the conf call and decide like who to block, who to freeze, and this is like really what caused the censorship in those systems. In the Bitcoin and Ethereum, it's not really better because you have really a strong concentration in terms of the mining pools. By economical design, there are this economy of scale for the mining pools, and they like really control the like large of the portion of hash rate. Mostly in China, you have like 80% of pools are in China, and 80% of the hash rate is now, let's say, in China. Ethereum is like have two controlling pools as well. The wealth is also very concentrated in those blockchains. If you look at the addresses, like what is their like Gini curve, Gini coefficient is 0.6 for the Bitcoin addresses and 0.76 for Ethereum addresses. So basically, you have like 72 addresses which control half of the wealth in the Bitcoin network. It's not necessarily a people, because you may have, for example, some exchange which has a hot wallet or a cold wallet which have many coins, but also you may have one individual which controls many addresses. So it's not really easy to reconstruct the real wealth distribution there. But it's still the problem that there is a very high concentration of powers in those decentralized networks. They meant to be like really like decentralized and independent, but in a sense you have some few actors which control one way or another control the network. And we think it's the root cause is the distribution of the capital, because they are based on basically the capital. You can buy the stake, or you can buy the hardware to mine this blockchain, and the capital has a very strong heavy-tailed Pareto distribution. So basically, you always have richest guys who have most of the power in society, and smaller players actually they suffer, and the rich get richer. And so the alternative ways to ensure some more like egalitarian setup is using a different Sybil protection mechanism. Like one of the attempts is like proof of person instead of like proof of work. If you have a way to ensure there's like a real person online, like some kind of one human, and this may be a good basis to also distribute the voting power and the mining power across this blockchain. And for this, you basically need to have some ways to ensure there is a real person online. So it's a real problem now. It's not solved. It's called the problem of unique human, or Sybil protected human, like Sybil protected identity. There is various approach, and if we solve this problem, we also can solve the problem of the governance in public networks. Instead of stakes, we can use the identities to govern, to vote. We can make decentralized oracles and prediction markets. So it's really like concept by itself is very powerful, but it's very difficult to do tests. And one of the approaches is based on the Turing test, which is language agnostic, based on the images. So it's called the flip challenge Turing test. So we have to solve some common sense based CAPTCHA, and you can look at those two stories. One is on the left, one is on the right, and there's a sequence of events which you can think what is more logical or more meaningful. So which one do you think could happen, and which one do you think less logical? So if we can vote, actually, I think most of you would say this is probably the left one. So whoever had the cat in the house, they experienced this. And actually, people are able to like solve this with 95% of accuracy on average on those flip tests. And AI is still bad at common sense, so they're still like not good enough in generalizing the knowledge out of the data, out of the language, and the kind of the peak accuracy is around 70% for AI to solve this. So basically, you can actually have the threshold to distinguish humans from like machines and have a Sybil protection in this network. So to kind of summarize, I think the time is running out. I find myself like very excited about what's going on now in this private money phenomena, and the Bitcoin, I think, is a great experiment. It's kind of a bit of a magic how the code was designed and launched, and without a change, is still running. And it's a way to introduce the global, like peer-to-peer, censorship-resistant internet money. But the problem is that it's not really scalable. So Bitcoin is, and the level 2 is not scalable. There's always a trade-off between scalability and decentralization. We don't want to lose decentralization in favor of scalability in transactions per second. We want to have really the independent networks with many agents which cannot collude and cannot kind of distort the governance. And there is a problem with this because we have like everything is based on capital, and capital has a Pareto distribution. It's very concentrated. And probably there's a call for new protocols which can solve those scalability and decentralization problems, and I'm very excited to share with you about it. And maybe the final remark, I invite, we'll have an event in February in Winter School. It's going to be the 10th anniversary of Winter School, where we talk about actually all the problems with scaling of consensus, with the governance, with financial markets, new financial market models, with new kinds of regulations which will be relevant for this new digital era space. So like welcome you all to Perm with this. So thanks.
Thank you.